Uh, every year I have seen a very advanced new version of PSPP. So one good thing about PSPP is that you don't have to bother about the licensing restrictions, and it never expires. So sometimes your this ethicality in research is raised that if you are using softwares like SPSS, whether do you have the license? Because using the cracked version or some patched version is illegal, illegitimate. So till now, the another option, open source option, available to the researchers were open source programming languages like R or Python for statistical analysis, but that requires a lot of coding to learn. And sometimes people from the social sciences, humanities, management find it hard to learn a programming language, that too for just doing a statistical analysis. On one hand, this mathematical application of that is transformed in the form of statistical analysis learning, this is a challenge. And then learning a new programming language or coding language. So here comes the free alternative to the SPSS or for the statistical analysis, where you can do statistical analysis just by clicks. It has the same interface almost as the SPSS, though some of the advanced features of SPSS they are not there in the PSPP, but yes, with the functionality of adding or using syntaxes, you can use almost all the syntaxes that are used in SPSS to run the statistical analysis in PSPP. So to start with, first let's see how to download and install this software. So simply, I hope my screen is visible.
No, sir. Yes, sir.
Now it's visible. So simply you have to search on the Google PSPP, nothing else. And the first, the gnu.org. You'll get this as a first result. Simply open it. Here on the download, you can go for the download. This was the actual page that I somewhere shared with you people. Let me show the link. So after clicking on download, you'll find the option for downloading on Linux, the option for downloading on Mac OS, option for downloading on Windows. So most probably all of us are using Windows, so you can use this Windows, or you can just go for Mac OS, or you can go for GNU license. So here just for Windows, go for installers. Here you will find different updates of PSPP. So the latest one is that was released on 5th of September 2020. So we have 32 bits and 64 bits. Based on whether you have the 32-bit system or 64-bit system, you can install the software. Simply click on it. You will be landed onto a third-party based source forge, because since it's an open software, so it's hosted on the source forge. It will start downloading by itself. And simply just wait. It will simply install the download the file and install it. That's it. And you will find, you will get PSPP like this. Almost you can see this kind of interface as you see in SPSS. It has the data view, the variable view, same as the SPSS. No differences there. So if you want to create a variable, let's say I have a questionnaire like this, where there is one independent, this is my dependent variable online trust having 13 items, and the privacy concern having 8 items. Fine. I want to create a variable for these. So as we do in SPSS, similarly we can do in PSPP. So let's name my variable like OT1, OT2, OT3, OT4, like that. So simply you go to, just hold on. Simply you go to this, as we type in SPSS, similarly OT1. Now my second variable is OT2. Will come, we'll go for these changes later on. Then OT3, OT4, OT5, OT6. One thing, is this software installed with you all? I have shared the download link, because it will be better that if you practice along with me, that would be better. Or if you don't have the link, you can just download it and install it. So first, just I'll let you know how to create the variables, because some might be new to this system, and then we'll work on some of the data files. OT7, OT8, 13 I had. I'm taking the first 8 only. If you see this questionnaire, it is having 8 items for measuring trust, measuring within the trust, and then another 5 items measuring the behavioral intent items. I'm leaving the behavioral intent items, only online trust items I'm taking. Now my independent variable is the privacy concern, again measured by 8 variables. So I'm just creating those 8 variables. So I'm naming it as PC. So PC1, PC2, PC3, so on. PC4, 5, 6, PC7, and PC8. Since these are numbers which I'll be taking, so it has to remain in numeric. By default, it has taken the width at 8. Let it be 8. Now, since we are taking this on a 5-point Likert scale ranging from 1 to 5, so the decimal will be only 0. Now, somewhat difference between SPSS and this is that there you have a drop down to select and minimize. Here it's minus or plus. So simply put it 0. And in SPSS, let me see if we can copy paste it. In SPSS also we had the option, and let's see if could be copy pasted, because I want 0 for all. Sorry. Do no, I have to go for manual entry. So I'll put all these as minus. While doing the entry, you can put all these to minus. Let me see. I think it should have some options like, yes, manually we can, one by one we can just change. I think no. So you have to change it manually. So for every variable, you have to process it. Now here in the value in the labels, simply I can put my questionnaire or whatever the items I want, whatever for the description purpose, whatever I want. So I'm just taking this one, just only one as an example. Simply just copy the and paste it as in SPSS we do. Simply put this as the label. Now value labels, again the same thing as in SPSS you find the value and the label command, here also you find. So one stands for strongly disagree, two stands for disagree, three stands for neutral, four stands for agree, and five stands for strongly. Okay. Now let me see whether we can, because in SPSS that's a functionality that you can copy paste it. Here it's a problem that you have to do it every time for every variable. So on right click is disabled, so you have to do it manually for all. So you can put in every that one is equal to strongly agree, two is equal to disagree, like that. Missing values none we want, column 8, alignment wherever you want, in the middle center, that doesn't make a difference. Measure, by default it's scale, whether you want it as ordinal or nominal. So here I have treated my values as a scaled value. Okay, absolute values. Okay, given some weights to them. So here it is the scale and role is by default input. Now you can see that all these variables have been created. If you hover over on these variables, you will also find the labels that you have put. So I have put the label only for one, so it will show only to one of them. So you hover over and you will find the labels also. Now coming to the entering the data similarly as we do in it's now what if this data is already there with you in Excel file? So this is how you create the variable. Yes, one thing here is that that's a added functionality in the this PSPP, that suppose if you feel that between OT1 and OT2 you have missed some variable and you want to put some other variable also. So simply you can right click here and insert variable. You'll find that one variable has already been created before OT1. Similarly, if you want to remove some variable, directly remove it from here. It will clear the variable. So you can do while you are entering the data at the same point of time, you can create a new variable and then edit that variable. Let's say I have inserted a variable and I can edit this variable over here by changing its name, label, whatever. If I want to clear it, where it has gone. Okay, I will clear from here. Today I have to clear this one. Okay, so OT1 was deleted by mistake, so I will create again OT1 and in the variable view I will change is as OT1 and then I will define its values. 1 is equal to E, 2 is equal to disagree, 3 is equal to neutral, 4 is equal to agree, 5 is equal to strongly agree. One thing that is uh, The same in SPSS, you will find that if you want to change this, simply you can edit this. Let's say if you want to change some values, you can simply edit that and click on apply. If you want to remove or add something new, you can do that. Sorry. So similarly, you can create the data labels, value labels, and data labels will be your questionnaire items. Now here we already have, now we can enter the data manually. Suppose if we already have a data prepared, now we can import that data over here. But the only problem with this software PSPP is that it reads CSV files, comma separated values or comma delimited value files. So it won't be able to read any other format. So you have to make sure that your data is already in CSV file. So uh, let me share with you a data set. So I have just shared with you the data set. You can just download it. Just quickly download it so that we can proceed forward. So this data is actually ppsp sample.csv. And here you can see that all those things that I have taken in the questionnaire are there. I only need this OT1, OT2, OT3, OT4, OT5, OT6, OT7 to OT8 and then PC1 to PC8. So what I'll do, I'll simply go for import data. I'll select the folder where it is saved. And it was the PSP sample. Click on next. Now I have to define here that which of the variables I want. I want all the cases or only the first few cases in numbers or in the percentage. So as of now, I have 52 cases and I will be taking all the cases. Now here it is giving me whether you want gender, age, respondent education, percentage, all these things. So what do you want? So I'll just go to next and I'll select what I want. I only want so I can go back and from here if it lets me select the values. So select the first line. No, I don't want this. I want all these values because I'll be putting this OT1 and OT2 like that. So select the lines to import. It's not taking this. Okay. So first have been removed. Now I have the values. Now what I want, that I have to see that. Click on the next. The variable view, it's showing me something like this. Let's see how it comes out to be. No, it's not the proper format. It's only taking one data. I have to select all. All cases. I want only these 8. So what I can do, I can just edit my CSV file first. Let me edit my CSV file that I want only those things. That's OT1 to OT8. So I'll be just removing these. Because sometimes somewhere there should be an option to choose what are the variables you want, but here it's not getting, so I'll just edit from here. So I had taken OT1 and gender, I need not, and then PC1 to PC8, rest I'll remove. Now this is my file as per the variables created. I'll simply import that file over here. So simply I will go to file, import data. Either if you want, you can create this variable before importing, or after importing also you can create these variables. And then to my folder where I have saved them. Simply I have to click on next, next, next. It will show me that this is the kind of data that you are getting. Apply. Why it is not imported? With this file saved, save. Okay. Fine. Next. Okay. Next. Apply. Yeah. Now I've got this data. Now the only thing is that if you see this CSV file, so it was having OT1 and OT2 also in the start. Okay, so this is comma delimited actually. So it has OT1 and OT2. See, OT1 and OT2 was not readable by this software because we have already given a command that already it will be numeric in nature. So it has left this first row. So you can simply delete it from here. its variable, it's case 1, right? You want to remove it, you have to just select this entire, how many variables it is taking. It is taking 68 plus 8. Simply clear this one. Now this is the entire 52 data set I am having. In the variable view, I can change their names, right? Like I have done OT1 to OT2, like that, whatever you want. As of now, let's keep it variable 1, 2, like that. So first 8 are from the means online trust, and the rest 8 are for privacy concern. Now let's say I want to measure the reliability of skills in this case. As I the preliminary step. Are you people there with me? Yes, everybody. Have you downloaded? Means have you? Do you have this data set? Okay. So I have imported the data which was in Excel. Now I can change the value of these, the name of these variables. But as of now, I'm keeping it just variable 1, 2, 3, 4. Only thing you have to remember: first 8 are for online trust, as we have seen here, and the rest 8 are for privacy concerns that we have taken in the CSV file. Now I have the data like this 1, 2, 3, 4, 5, like this. I want to check the reliability. The first thing. So simply I'll go to analyze, click on reliability, and I'll take all those variables on which I want to check the reliability. So I'll just select all over here. By default it's alpha. If we want a split method, means if we are going for a split method, then we can go for else alpha method. Click on OK. As SPSS gives output in a separate file, similarly you will also get the output in PSPP IRE file, which is its output viewer. And here you can see what is the value of our Cronbach alpha, 0.89. The thumb rule that if Cronbach alpha value is more than 0.1, oh sorry, more than 0.6 or 0.7, basically it said it's 0.7 or more than that, then your skill stands reliable. So this is how we can do the reliability test in this. Similarly, if we want to do the test of if we want to do some descriptive statistics, such as we want to count the frequencies, let's say for variable 1 and variable 2, variable 3, like that. Let's say for these 3 variables, I want to count the frequencies and I want to build the charts also. So simply you can click here on the charts also. If you want the histogram, you can go for histogram. If you want the bar chart, you can go for bar chart. If you want pie chart, you can go for pie chart. If you want the frequency, then you can take the frequency. If you want the percentage, you can take it in percentage. Let's say I want to draw pie charts and I want to take, okay, continue. Frequency tables, I want in ascending and always, continue. Click on OK. So here you will get the output, the frequency chart for all the 3 variables, the minimum, the mean, the standard deviation, the minimum value, the maximum value, and you will get the frequency chart like this. However, as of now, labeling this frequency chart is not available in PSPP. In chart builder, you can do in SPSS, but if you want, you can simply export this entire results into a file, PDF file. So simply select here PDF, name the file, and you can save it as a PDF file. So this is how you will get the frequency distributions. Now I want to apply some basic uh, data test on this. Like I want to check for missing variables. For that, let's remove a few of the variables and then we can check the missing variables. So it happens that by mistake or during the entry, you have omitted some or you haven't entered some values. But if it's a huge data set manually, it cannot be seen. So if you want to check that, simply you can go to again the descriptive statistics, frequencies. Here you have to select include missing values. So same three variables. I'm taking as of now all the variables because I have done some random changes. So let's see all the variables. Here you have to select the missing values. I don't want minimum, maximum, mean, standard deviation. I want okay. Frequency table by default it will be selected. If I want, I can also put a condition that I want a frequency table if no more than 50 values are there. Like this, I can put a condition. Anyways, here click on OK and see. So in the first variable, none is missing. Second variable, none is missing. Third variable, one is missing. Fourth variable, nothing is missing. Fifth variable, nothing is missing. Sixth variable, nothing is missing. Seventh variable, one is missing. Similarly, in the 12th variable, one value is missing that I have just deleted. So sometimes it happens that while entering the data, it might be a case that respondent has not provided response to a particular question, but for one question you cannot drop that respondent. Or sometimes while you are doing the data entry, you forgot a particular statement or entry of its value of a particular respondent. So it will be, suppose if you have lot number of questionnaires, then it will be, and if they are not in order, then it will be a problematic situation for you to replace this missing value. First thing is identification, and then second thing is replacement of these missing values. Because see, in this case, only one values are missing. That won't make a big difference. But suppose if three or four values out of 52 they are missing, miscounted at zero, that could affect your mean value to a significant level. So you have to replace these missing values. So let's see, variable third has one missing. Let's see where it is missing. Variable third. Can anybody point out the missing value in variable 3? There's something missing in this. Okay, this was our data set, sorry. It has opened another data set. I'm not working on this one. Shit. It is closed all. Again, I have to do the same activity again, remove some numbers. check for the missing values. Equal C is select the missing values, deselect the minimum, maximum, select all these, click on OK. That has given me an output. Yes, in variable 3 1 is missing, 5 is 1 is missing, and in 12 1 is missing. So let's see how to replace them. So in variable 3 this one is missing. Now one method could be that I go back to that particular respondent number 6 questionnaire and replace this value. But what if there are a lot of pile of questionnaires? Then it will be a cumbersome process. What if this respondent has not given the response? Then for only this one non-response, I cannot drop the entire respondent, because then I have to, in a different questions, some are missing, I have to drop every many of the respondent. So better thing is to replace this missing value. And the thumb rule says that you have to replace the missing values by taking the mean of the preceding value and the succeeding value. That won't be the accurate value, because this would have been something else, but yes, it will normalize the mean to a significant level. So if you take the mean value of 5 and 2, it comes out to be 3.7, and then rounded off to the nearest 3.5 and rounded off to the nearest decimal, this stands 4. Similarly, in variable 5, 4 plus 4, again its mean will be 4. And then we had missing in variable 12, where, let's see, sorry, we have a missing value in variable, yeah, 12, we have one missing. Now let's see where it is missing. Yeah, here. So 4 and 2, the respondent number 50 is missing. So on the variable 12, so 4 plus 2, 6, and take the mean value. So by this we will replace the missing values. Now second thing is, once we have replaced everything, now second thing is, suppose if at some stage I identify that this entire data is wrongly coded. What should be 1 is coded as 5, and what should be 5 is coded at 1. Completely reverse. Or you can say what should be 2, exactly it is 3. I have wrongly coded something. So I want to change it. This is all the step of data coding and cleaning. So I would simply go to transform and will select recode into same variables. Let's say in variable 1 I haven't identified that what should be coded as 5 has been wrongly coded as 1. I will take this variable, select it, and then here I'll simply add the old value and the new value. Only this one. Rest I think that it's fine. Continue. Okay. Now see, whatever has been coded as 1 has been again recoded as 5. Similarly, if I want to, let's say there is a category called age. Let me take this age category from, no, not from here. Okay. Let me say that I have a category called age, a variable I have created. Let me create. Now I have taken ages like this one. Let's say open category ages. Now, at one point of time, I realized that these open category ages are of no use to me until and unless I convert them into category. So it is like 25 to 30 should be one category, 31 to uh, let's say 35 should be another category, like this. So one thing that I go on the 25 change it to 1, go on 32 change it to 2, go on 35 change it to 2, go on to 49 39 change it to 3. But if there are a lot of data, it will create a problem for me. Here I can apply this one, record into different variables. Simply it's the age category that I have taken. I will just name it age categorized, age categorized underscore. And here also I'm saying label as age categorized. Now old and the new values. Now here I will define the range. But before defining my range, I have to do one thing. And that is, first I have to know what is my minimum range and the maximum range. So you can do it by going to frequencies and selecting only minimum and maximum. So you will come to know about the minimum age and the maximum age. So minimum age that I have taken is 25 and the maximum age that I have taken is 43. So my age range will be from 25 to 43. Now it depends on me whether I want to create an interval of 5, 10, whatever. So here I'm just creating an interval of 5. So 25 to 30 will be categorized as 1, 31 to 35 will be categorized as 2, 35 to uh, 36 to 40 will be categorized as 3, and so on. So let's do that thing on this. So now I will go to transform. I can choose record into same variable if I want all these to be transformed into categories. But if I want to know that, okay, which age I have categorized in which category, so better take record into different variables. Already I have taken age categorized, age is there. Old and the new values, here I will select simply range. So my first range is from 25 to 30. Add. Now second range is from 31 to 35. Add. Third range is from 36 to 40. Add. Fourth range is from 41 to 45. 43 is my highest number. So I have created 4 age categories. Continue. Change. Okay. Now here you can see that as per the category defined by you, the age has been categorized. And now I can use these age categories for further calculating or further computation of some test. Or suppose if I want to test the effect of age categories on, let's say I want to apply some independent t-test or dependent t-test, or some ANOVA, that how different age categories have different perceptions towards online trust. Like this, if I want, I can do this. But this is a kind of transformation which will be done only when these A's are given as open-ended, and I want to convert them into categories. Now, second thing is that I have taken 8 variables to measure online trust. I have taken 8 variables to measure the privacy concern, but what is the actual score of online trust? These are the scores given on different items that were measuring the online trust. What is the overall score of online trust? So if you are treating this scale that you have taken as a ordinal scale, then you will measure the median value. Else, either measure the mean value or the summated value. So let's say I want to take the summated score of the 8 variables which we are measuring online trust. So either I can do a total summation of all these manually, but here I have an option to compute a completely new variable containing the sum of online trust, and I can use label as sum of online trust. Continue. Now if I have a summation score RS, so I can find the square root. So here I have taken this, and I'll simply take variable 1, variable 2, variable 3, variable 4, 5, 6, 7, 8. I'll separate all these with comma. Click on OK, and now you will find a new variable with the name sumOT created, having summated scores of all those 8 variables. Similarly, you can do for privacy concern 9 to 16. Now here I want to calculate the mean, let's say. So again, for 9 to 16, I want to calculate the mean, just for example. Remove this and take the mean over here, from here, and take those variables whose now here I will just change mean, and it's mean of privacy concern, so it will be named as mean underscore pc, and mean underscore pc. Now if I want this target variable name to be used as label, then I can by default select use expression as label. If I want to put my own label, so I can use my own label, mean score of privacy concern. Now select variable 1, 9, 10, 11, 12. You have to select one by one. 13, 14, 15, 16. Remove this question mark. Separate all by commas, all the variables. Click on OK, and you'll find a new variable created with the mean values of all of them. Since we have taken on a scale of 5, so simply we can define that I want this scores to be absolute numbers, not in decimals. Now it will round off to the next decimal. Now you have got the mean score. So these things you can perform, you can recode, you can transform, you can take the square root, logarithm, whatever function you want. You can go through compute variables and do this. Now another thing is, if suppose now my data is cleaned, code, transform. Now some basic.
Sir, what's the use of mean and summation over here?
See, I have measured online trust on 8 parameters, right? What is the actual score of online trust? Because online trust for, let's see here, it's online trust as given by respondent 1 for this question. Online newspaper appears to be more trustworthy than television networks. This is for the first question only, OT1. All the 52 respondents have responded. Similarly, for OT2, for this question, all the respondents have responded. All these are measuring online trust. So, what will be the actual score of online trust? Are you getting my point?
Yes, sir.
Because all these are measuring the respondents' response on these 8 questions. But what is the actual score of online trust? So either it is will be the mean value of this or the summated value. So if you are measuring something which is absolute in nature on a continuous scale, then you will summate it. Else you will take the mean value. When you are taking a when you have treated this Likert scale as interval scale. If this Likert scale is treated as a ordinal scale, then you will take the median values. Right? This will give you the overall score of the dimension that you are measuring. Am I clear on this part?
Yes, sir. Yes, sir.
Okay. So these are the transformations that you can do, because after collecting data, you have to do all these transformations. Suppose you have 4 variables, 100 items missing those 4 variables, but at the end of the day, you have to do the analysis of those 4 variables only, not those 100 items. So you have to get either the mean score or the summated score of all the variables missing those 4 variables. This you can do by compute variable command. After that, now your data is properly coded, properly transformed. Now there are some basic assumptions that has to be tested. And the very basic assumption is the test for normality. So I have already given you a data set for normality. Please open that. Now here I am opening the new data file. Open. Wherever you have saved, please open that. Sorry, import data. So this normal distribution one.csv. So these two variables are just created out of mistake. So because the data is like that. So simply serum protein in kg per ml I have taken. So I need not these. So I'll just remove these. I have to take only this one. Clear cases. And I have to remove this variable also. Now I have this data set. I want to check that whether this data is normally distributed or not. This is the serum protein of individuals taken at a particular point of time. I want to check whether this data is normally distributed or not. You can test it on any data. Since this data is made like this for checking the normal distribution, so I'm taking this as an example. You can just download this, export this data, sorry, import this data and run a analysis. So there are three methods of checking the normality. First one is by histogram. Second one is one sample Kolmogorov-Smirnov or one sample KS. Third one is Shapiro-Wilk method for smaller sample sizes. And fourth one is through QQ plots. You can use any of them. But here SPSS only supports, PSPP only supports, all these four are supported in SPSS. PSPP supports only normal distribution and normal distribution curve over the histogram, which is the graphical representation, and one sample case. And I think that should be sufficient for checking any of the data set for normality. So you can simply go to analyze. First, let's see the graphical method. Leave analyze. Go to simply histogram. Select the variable. Display normal curve. You will get a histogram. See in the output. If you closely look at the data, what does this represents? The pattern. Can anybody tell me? Can anybody respond? Somebody has said, asked Dr. Anjani Srivastav, sir, which downloads of software is suitable for Windows 10? Sir, Windows 10 you can download 64 bits, sir. The latest 64 bit. Okay. Now, what does this figure represents? If you
The normal distribution.
It is normally distributed. Same thing you can cross-check through statistical analysis. That is one sample called Kolmogorov-Smirnov. This was my data set which I was working upon. Analyze. Go to non-parametric statistics, one sample KS. Select this. Select normal distribution you want to check. You can check normal, uniform, exponential, Poisson distribution, any of this. So here we want to check normal. Select OK. Go to the output. Is our p-value significant or insignificant in this case? .915. So normally we say that significance is there only when p is less than alpha. Here p is greater than 0.05. So what can we infer from this? See, whenever we frame hypothesis for normal distribution or hypothesis for heterogeneity of variance, we frame null hypothesis as the test distribution is normal. So here what is happening? The hypothesis is accepted or rejected? Anybody from the audience? Is our hypothesis accepted or rejected based on the basis of this p-value?
Sir, rejected
If it is
because it's
if
not
it is
significant.
This is
the p-value is
accepted.
less than 0.05, it null hypothesis is rejected.
So here it is more than 0.05. So null hypothesis is?
Accepted.
And what was our null hypothesis?
Okay.
Test distribution is normal. So this was our null. Okay, one thing. Why now I can sense why people are getting confused over whether it should be a null hypothesis or not. Let me tell you, many people are having the notion that null hypothesis is always negative in statement, isn't it? And alternative is always positive in statement. Now, I am saying that I have gone through 10 studies, and all the 10 studies have said that eating butter has nothing to do with cholesterol. Now, what should be my null hypothesis here? Anyone from the audience, please. I want to make it interactive because this is the basic wrong notion that is among many researchers that every negative statement is a null hypothesis. Now, I have studied 10 literatures or 10 clinical researchers, and all have suggested me that eating butter has nothing to do with cholesterol. Now, what should be my null hypothesis here?
Eating butter has no effect on cholesterol.
So that has been suggested by literature, na, कि eating butter has nothing to do with cholesterol. So if I am putting the same hypothesis as my null hypothesis, what is the point of testing that? Already it has been established. Are you getting my point?
Yes, sir.
So already literatures have said, studies have said that eating butter has nothing to do with cholesterol. So if I'm framing the same as my null hypothesis, there is no point in testing. I'm saying the same thing. So I will say, no, I want to test that whether it stands true or not in my research. So the first thing that I will do, I will negate all those studies. I will say I do not agree. So in this case, my null hypothesis will become eating butter have significant effect on cholesterol, and my alternate will become there is no effect of butter on cholesterol. Because if I put my null hypothesis as the same as the previous studies, there is no point in testing it. If I am agreeing to their statement, there is no point in testing it. So,
Right, sir.
so this misconception that null hypothesis is negative, it's not correct, partially correct. Null hypothesis is negative of whatever the previous studies suggest, negation of that. So it could be it's not a case that always null hypothesis is negative in nature. Okay. So here, why I am saying that test distribution is normal, that's my null hypothesis. Because if already I take this assumption that test distribution is not normal, what a point in testing? If I take this as my null hypothesis, that test distribution is not normal, then okay, there is no point in testing it. I'm saying that null hypothesis, that test distribution is normal. Let me check whether this is the case or not. So either you can keep this in mind that P is less, null hypothesis in this case is that uh, data is normally distributed, or simply you can say that if P value here is more than 0.05, you can simply write that test distribution is normal. Simply you can say if P is more than 0.05, test distribution is normal. If it is less than 0.05, test distribution is not normal or skewed. Or further, if you want to elaborate, you can elaborate that our null hypothesis was test distribution was normal. Due to these results, the null hypothesis is accepted, and thus test distribution stands normal. Am I clear on this?
Yes, sir.
Okay. Now, second assumption that we test is test of homogeneity of variances. Whether your sample is, suppose if you have two categories and then you have to two or three or four or many categories of your within your population, and you want to see that whatever the variable you are checking, whether that is homogenetically distributed or not. For that, we use the statistic known as Levin's test of homogeneity of variance. So that can be done. Let me open the data for you. Levin test. Now I have got this data. Now just let me code this, because see, this is the serum protein level. Here, only one thing that I need to do, I have to put one for male and two for female. Now I have two categories of my respondents, and I want to check that whether the serum protein is distributed homogenetically among the male and females or not. Because normally when we go for an independent t-test or such, we get two values. One is equal variances assumed and one is equal variances not assumed. So before that, we have to check that whether the data is homogenetically distributed or heterogenetically distributed. If data is homogenetically distributed, then we can say that we will take the statistic of equal variances assumed, else equal variances not assumed, or there will be no point. If your data is not homogenetically distributed, there is no point in testing for independent t-test, or there is no point in testing correlation. There is no point in testing regression, because homoscedasticity of data is one of the assumptions. Just after normality, you have to check for the data is whether homogenetically distributed or not. Homoscedasticity is there or not. Heteroscedasticity shouldn't be there. So that can again be checked by going to analyze, compare means, and take 1 by ANOVA. Take these two variables. Dependent variable is one and factor is your. So before making it factor, here you have to describe it as nominal, because this is categorical scale. Now go to analyze, compare means, 1 by ANOVA. Take this into factor. Here you will get this homogeneity tab. Click it. Okay. And let's see the table. So this is the Levin statistic. Again, here my null hypothesis, because I have said in case of testing of assumptions, because that is already assumption that you are testing that whether the data is normally distributed or homoscedic or not. So you have to frame the null hypothesis here also, that data is homogenetic in nature. Means data is distributed across male and female. Serum protein is distributed across male and female in homogenetically. It's not heterogenetically distributed. So here my null hypothesis is that my data set is homogenetic in nature. Now again, if you see the P, null hypothesis is accepted, less than greater than 0.05, and my null hypothesis what data is homoscedic. So based on the Levin's test of homogeneity of variances, I can say that that serum protein is homogeneously distributed among my categories or among male and female. So there is no problem of heteroscedicity, and we can perform regression, correlation, independent t-test like that. Because for particularly for regression, you have to check the data does not have heterogeneity. So there are three basic assumptions that are required. First one is in case of regression at least that data should be normally distributed. There shouldn't be any heteroscedicity in the data, and there shouldn't be any multicollinearity in the data. When we'll be doing the regression analysis, I'll tell you about multicollinearity also. So that's for today, the basic operations that we do on the PSPP. Similar to SPSS, the only good thing with PSPP is it is free. So I'm done for today. Hope it might be a learning session for you. Tomorrow we'll do the t-test and ANOVA on the same PSPP. I'll share the data sets for doing that. And till now,